Okay everyone, we're going to continue here with video AM-E2, our second exponential solving video. And I want you to take some notes here on this type of exponential equation. These are ones, you guys, that require using logarithms, including also using the change of base property possibly. Reason why this is that we're going to be using logarithms in this type of equation is because we have not got the same base on each side. And of course the values that you're going to see in these problems, one side might possibly be from the power table, but in general they are not both power table values that are related to each other. So keep that in mind. So for example 5 here, we need to solve for b, the instructions say, and we want to round to the nearest 10,000th. That's 4 places, just to remind you, okay? 4 decimal places. Tenths, hundredths, thousands, 10,000ths, 4 places. So for this first one, we want to say 3 to what power equals 17. In order to do this, we're going to take the log of both sides, and that's just the common log base 10, so we don't need to write a subscript. So we've got log of 3 to the b on one side equals log of 17. And if I remember what happens with my exponent, when I have a log with an exponent, remember that comes down in the front of the logarithm. So this is going to turn into b times log of 3 equals log of 17. And then if I want to solve for b, I'm going to get that b is equal to log of 17 all over log of 3. Now I also want to just give you another way to think through this. If you were to go back to the beginning of this problem and simply rewrite the exponential equation that you see there in logarithmic form, that would become the log base 3 of 17. And then we have a formula called the change of base formula. I'll just put COB here. That can lead us directly from the logarithmic form here right straight to a ratio of common logs here, meaning the log of 17 divided by the ratio to log of 3. And I'll just remind you again that whatever that base is on the log will be in the basement part of the fraction, or the denominator part of the fraction. So just keep in mind that's a separate way to do it if you want to. You certainly don't have to. You can do it in the way that's in black there instead of the blue. But either way, you'll get to the same exact value, which we then just need to calculate on our calculators. And that will be 2.5789 if we go out to 4 places. So go ahead and write that in on our answer blank there. Okay, and so that's the example of an equation to use a logarithm to solve it, because you do not see a power table relationship. So next I want you to pause your video here and work on the even number example 6, the we do, and make sure that when you're done you check your answer with your teacher before you move on to the next part of the video. Okay, in this second part of the video here we're going to be doing an exponential equation that has a base of our special number e. So take notes on this example 7 with me here. The instructions say to solve for n, and we're going to do the same rounding as the first example that you saw in the video, so to 4 places. Keep that in mind, to the 10,000th place. Next we're going to look at this equation, and if we want to get our n alone, we notice that our n is in the exponent, so we first want to think about isolating the exponential part. That's this whole entire expression right there, e to the 8n plus 8. That's our goal, is to get that alone. So we're just going to use algebra to kind of peel away the layers here. What we need to do first is add our 3. So we're going to be at negative 6e to the 8n plus 8. And then if we add 3, we get equals negative 20. Next step to get e to the 8n plus 8 alone first is to now divide by our negative 6. So we're going to get e to the 8n plus 8 is going to equal, if I divide and then reduce, we get 10/3 there. And so now that I have e to the 8n plus 8 alone, I know that I can reverse the e base of the exponential by taking the log of the same base. So that, remember, is the natural log of both sides. So what we're going to have happen here is that on the left-hand side, ln of e, remember, is 1. So if we pull that 8n plus 8 down in front as the exponent times ln of e on the front end, what's going to happen is that ln of e is simply going to cancel out because that's just the value of 1, remember, with our special properties that you see on the board on your poster there. So this is just 8n plus 8 now is all by itself, and I'm going to set that equal to the ln, or natural log, of 10/3. So now this is just calculator work from here on out, you guys. We're going to get 8n plus 8 is going to equal approximately, so I should probably make that a squiggle equal, 1.203. Now we'll go to 5 places because we're not quite at the end here. We'll round it to 4 places at the very last time that we are getting a variable. We're not quite solved yet. So now we're going to get 8n alone by subtracting, and that approximately is going to be negative 6.79603. Again, go to 5 places. We're not to the end yet. And then finally divide by 8, and we get our answer. And it's going to be approximately negative 0.8495. This is all just using my calculator and my ln key, which, remember, is on the side, on the left-hand side column of buttons there. You're going to use that built-in function. So my answer in my answer blank is negative 0.8495. And now I'd like you to go ahead and do the we do part, checking your answer with your teacher when you're done. Do example 8 and see if you can follow some similar steps to get an answer approximated to 4 decimal places there. So take a pause on your video. Alright, in this final I do portion of video AM-E2 here, we're going to be taking notes on example 9, which is another exponential equation that you're definitely going to need to use a logarithm to solve, and it's also going to include possible change of base properties, and probably a little bit harder, a few more steps involved than we had in the first few examples here. So the first step we want to do is to get, again, the exponential part all isolated. So I think an easy step there is just to subtract our 3. So we're going to get 9 to the n plus 10 equals just 78. And then if we take the log, and I'm just doing a common log of both sides there, log of 9 to the n plus 10 equals log of 78. Then, of course, we know the n plus 10 as the exponent comes down in the front of, sorry about the messiness of this stylus here, of log of 9 equals log of 78. Boy, this is horrible. Forgive me. So that's n plus 10, that should say, times log of 9 equals log of 78. And then, of course, we're going to get the n plus 10 alone by doing a division. And then remember, we're going to approximate that with our calculator. So for this one I get approximately 1.98282, go out to 5 places, and then round at the very end here, a quick subtraction, and we're going to get negative 8.0 0.0172 for our final answer. And again, I'll just remind you that you can treat this once we get to the step right here of n9 to the n plus 10 equals 78. We could rewrite that if you wanted to as log base 9 of 78 equals n plus 10. And then if we did that, our change of base would get us right to the ratio of the log of 78 over the log of 9. A couple of different ways to think through it, same answer either way. So now I want you to pause your video here because we're at the end, and this is the final one on this video of the We Do examples that you need to check with your teacher following some similar steps.